Right, if you can hear me loud and clear, please put a message on the chat below. If you can hear me loud and clear, just put a message on the chat. Right, good evening, everybody. We'll discuss the past paper questions in the refraction tube. That's easier because some of you all were requesting it. So page number 7, question number 2 in the refraction tube. Page number 7, page 7, question number 2 in the refraction tube. Right. State the conditions under which total internal reflection occurs. So what are the conditions? First one, light rays should travel from denser to rarer. Condition number 1, light rays should travel from denser to rarer. What is your second condition? The angle of incidence must be greater than the critical angle. The angle of incidence must be greater than the critical angle. Okay. Right. Now look at this carefully. I've given you a question like this. Here we have filled it with water. Here you have water. And then there is a oil layer. Oil is floating on water. So here you have oil. Here you have water. Right. So what's happening? Light rays come directly in. Light ray comes directly in. I'll draw the normal here. Using your mechanics knowledge, you can easily say theta here means theta here, theta there means theta there. There you go. What is the question they are saying? A layer of clear oil is contained over some water in a wide rectangular dish. The bottom of this dish is silvered like a plane mirror. So this part is silvered like a plane mirror. This part is silvered like a plane mirror. There you go. Silvered like a plane mirror. A ray of monochromatic light is incident on the surface of oil normal to it. If the refractive indices of oil and water are given. So refractive index of water is 4 over 3. What is 4 over 3? 1.33. Refractive index of oil is given 7 over 5, 1.2. Remember, optical density is different. Physical volumetric density is different. So here this is more optically now. This is 1.33. This is 1.4. This is more optically denser. Optically denser. Right. Higher refractive index. So what's the question? Determine the maximum value for theta for which the light rays after traveling through liquids emerges into oil-air interface. Oil-air interface. So here, with the normal angle theta means, angle of incidence equals angle of reflection. Angle of incidence equals angle of reflection. So here also theta. Here also theta. Here you have the normal. Now rarer dense towards the normal. Emerges into air. Emerges into air means goes along the boundary. Goes along the boundary. Problem solved. Now carefully work this out. So guaranteed here critical angle, here also critical angle. If you take this normal here, here also normal, these two are parallel. Parallel means here Z is formed. Here 2 theta, here also 2 theta. Finished. No? Easy. So now you can find it. So how will you find it here? You can easily say refractive index of oil sin C, refractive index of air sin 90. So for oil you have 705 sin C sin 90. Sin C is equal to 5 divided by 7. So here 5 divided by 7 sin C. Now we can apply here. Refractive index of water sin 2 theta. Refractive index of water sin 2 theta. Refractive index of oil sin C. Here 4 over 3 sin 2 theta. Here you have 7 divided by 5. 7 divided by 5. Sin C is 5 over 7. 4 over 3 sin 2 theta. These two cancel off 1. Sin 2 theta is equal to 3 divided by 4. Sin 2 theta is 3 divided by 4. Now your job is you must find theta. So 2 theta is equal to sin inverse 3 divided by 4. 48 degrees 35 minutes I think. Sin inverse 3 divided by 4. So half of 48 degrees 35 minutes. So 24 degrees 18 minutes. 24 degrees approximately 18 minutes. 24 degrees 18 minutes you will get your answer. Okay? Or you can simplify and get it. So that is one past paper question that we have done. One past paper question, very direct. Easily you can get the answers. There is no difficulty. Right. Next past paper question. Next past paper question. Question number 3. Why does the refractive index vary from medium to medium? It's a very good question. So why does it change from medium to medium? From medium to medium, the speed will change. Speed of light in the medium will change. When the speed of light changes, the refractive index will change. Right there. From medium to medium, the speed of light in that medium will change. From medium to medium, the speed of light in that medium will change. From medium to medium, the speed of light in that medium will change. Therefore, the refractive index will also change. Therefore, the refractive index will also change. Therefore, the refractive index will also change. Right? So what are they giving you here? As shown in the figure, a monochromatic ray of light in air is incident on the surface of a spherical water droplet A. Spherical water droplet. So this is water. Outside you have air. Don't forget. So if you draw this carefully, so this is what they are saying. Angle of incidence here, I, rarer, denser towards the normal. Center is somewhere here. Here R. Here also R. Why? These two are radiuses. These also are. These also are. Light ray will come out. So here you have A, B, and C. Right. A, B, and C. So what are they asking you? What is the value? What is the value for the angle of emergence? So angle of emergence, I'll mark it as I1 will. So here R means these two are equal radius. If they are equal, opposite angles are equal, R and R. Here partial reflection will take place. Partial reflection means here also R. Partial reflection means here also R. These two are radiuses, here also R. Let me find the angle of emergence. So looking at this reversibility of light, Roman number 1. I think Roman number 1 I can answer here. NA sin I, NW sin R. Also here, NW sin R, NA sin I1. These two are equal means these two are equal. Therefore, NA sin I is NA sin I1. Sin I equals sin I1. Therefore, I equals I1. Angle of emergence that is equal to I. That is equal to I. Derive an expression for the total deviation. Roman 2. Now remember, light ray path has been changed. It has been changed here, it has been changed here, it has been changed here. This is the deviation at A. This is the deviation at B. This is the deviation at C. So total deviation is deviation at A, deviation at B, deviation at C. What is the deviation at A? Vertically opposite angles are equal. This is I, this is R, I minus R. Clockwise. Here, angles along a straight line 180. 180 minus 2R clockwise. 180 minus 2R clockwise plus. Angles along a straight line here, R means here R, these I1, no, these I, no. I minus R. I minus R clockwise. Total deviation. Now all angles are clockwise, so you can add it. Clockwise deviation. I minus R, 180 minus 2R, I minus R. Simplify it. 180 plus 2I minus 4R. 180 plus 2I minus 4R. That's your total deviation. That's your total deviation. Okay. Then what? Roman number 3. If I is equal to 30, total deviation is 156. Calculate the refractive index. So now you know the total deviation. You can substitute for this. Total deviation, that is equal to 180 minus 2i or plus 2i minus 4r. Total deviation is 156. 2 times I is 30 minus 4r. 4r is 240 minus 156. How much? 40, 40, 80, 84. 84 4r. R is equal to 21. So R equals 21 found. R equal 21 found. Calculate the refractive index. That's the whole idea. So Na sine I equals Nw sine R. Sine 30 Nw sine 21. Nw is equal to sine 30 divided by sine 21. Sine 30 divided by sine 21, if you simplify it, you can get something close to 1.4. Sine 30 divided by 1.395. So 1.4. So refractive index 1.4 approximate. 1.395 refractive index 1.4. Roman 4. Roman 4. Can the ray suffer total internal reflection on the opposite side? Justify your answer. So we must show that it can't suffer total internal reflection. Now look at this very carefully. Here, maximum angle of incidence. I will show it below. Maximum angle of incidence is 90. Maximum angle of incidence is 90. So light ray will go along the boundary or critical angle. Again, draw normal will. So here critical angle means these two are radiuses. Here also critical angle. That means think carefully and tell me, can total internal reflection occur? Never. Total internal reflection can occur only if the angle of incidence is what? More than the critical angle. So here you can show I maximum is 90. Therefore, R maximum is critical angle can never exceed critical angle Therefore, total internal reflection can never occur. Total internal reflection can never occur. So here, critical reflection can take place. Now here, critical reflection can take place, but total internal reflection can never occur. Why? R max never exceeds critical angle. So what happens here, once it comes out, light rays will go along the boundary. So when is increasing, R is increasing, I maximum 90, R maximum C, total internal reflection can never take place. No? Total internal reflection can never take place. Right. There you go. Right. Question number 4. Question number 4, again past paper question. Question number 4, past paper question. Read. Figure shows a vertical cross section of a shallow circular pond covered with a thick glass plate, thickness 4 centimeter, refractive index 3 divided by 2. Refractive index 3 divided by 2. So here you go. Something like this. Here you have water. Here you have water. And here you have glass. Glass and you have water. Glass, you have water. Right. So what are they asking you? Figure shows a vertical cross section of a shallow circular pond covered with a thick glass plate, thickness 4 centimeter. Thickness 4 centimeter. Pond contains water up to the lower surface of the glass plate. A point source is kept at the bottom. Depth of the water in the pond is 30. Depth of the water in the pond is 30, right? Looking at the pond from above, we'll see a circular patch of light. Explain briefly how a circular patch of light can form. You can draw a picture and show, diagram and show. You have a source here. Light ray directly travels into air. That's one. Refractive index 3 over to 1.5. Refractive index of water 1.4. Rarer, denser. Light ray travels like this. Rarer, denser towards the normal. Denser, rarer away from the normal. So what do you mean by circular patch? Circular patch means light rays go along the boundary. So somebody looking from top. Somebody looking from top. From here, light rays will go to the eye. But beyond this, no light rays will occur. Because total internal reflection will take place. So from top, when you see, you can see a circular patch. So after drawing this, you can add a small sentence. As shown, when viewed from top. As shown, when viewed from top. As shown when viewed from top. Light rays will refract. Light rays will refract. Light rays will refract. And beyond a certain point, no light rays move out. And beyond a certain point, no light rays move out. And beyond a certain point, no light rays move out. Beyond a certain point, no light rays move out. Therefore, when viewed from top, we can see a circular patch. When viewed from top, we can see a circular patch. Right? Part B, using only standard laws of refraction and geometry, calculate the radius of the circular patch seen on the glass plate. So now radius of the patch is this radius. Here there is a distance called x. And don't forget this distance here is y. X plus Y is only R. X plus Y is only R. Look at the board carefully. Here critical angle, here critical angle, here angle of incidence, here angle of incidence. Carefully work backwards. Carefully work backwards. Here, NG sin C equals NA sin 90. NG is 3 over 2 sin C. Sin C is equal to 2 over 3. Now, if you look at this point here, I'll name this S, P, Q, R. Okay. If you look at this right angle triangle here, this length is there 4 centimeter. Here critical angle, here 90. This is your distance Y. We can easily say from the right angle triangle here, opposite over hypotenuse, 9 minus 4 is root 5. So we can say tan C is equal to opposite over adjacent. Also tan C is equal to 2 over root 5. Y over 4. Y is equal to 8 over root 5 centimeters. 8 over root 5 centimeters. 8 over root 5 centimeters. Then look at this carefully. Here let's say T. If you apply here, I'll do it here. NW sin I, NG sin C. 4 over 3 sin I. 3 over 2 sin C is 2 over 3. 1. Sin I is 3 divided by 4. Now if you take this triangle here, this distance is X. This distance is 30. Also don't forget your right angle triangle here. Opposite over hypotenuse 4. 16 minus 9 root 7. From this you can say tan I is equal to opposite over adjacent. Tan I is 3 over root 7. X over 30. X equal 90 over root 7 centimeters. So here we have found separately X. We have found separately Y. Now you can therefore say radius is X plus Y. Radius is going to be 90 divided by root 7 plus 8 divided by root 5. At least for 2 decimal places, you can keep your answer. 90 divided by root 7. 90 divided by square root 7. Root 7 is 2.64. 2.65. 90 divided by 2.65. 33.96. So 37.5. 37.5 centimeters. So there you go, the radius. 37.5 radius. So we have separately found X. We have separately found Y. X plus Y is equal to what? Radius. X plus Y is equal to the radius. Okay. X plus Y equals radius. Right. Okay. Part C. What will happen to the diameter of the circular patch when another layer of water is placed on the circular glass plate? If you put a layer, what happen? The radius of the patch will further increase. Right there. The radius of the patch will further increase because the radius of the patch will further increase because from glass to water, light rays will refract. From glass to water, light rays will refract. From glass to water, light rays will refract. And from water to air, light rays will emerge. And from water to air, light rays will emerge along the boundary. And from water to air, light rays will emerge along the boundary. From water to air, light rays will emerge along the boundary. Okay. Light rays will emerge along the boundary. Right. Part D. Radius of the pond is 45 centimeter. Calculate the minimum thickness of the water layer mentioned in part C. Actually, now you can draw this a bit bigger. What are they asking? If the radius of the pond is 45 centimeters, calculate the minimum thickness of the water layer. You need to make sure light patch covers the entire top surface. Entire top surface. So here you have water. Here you have glass. Again, you're going to use water. Why? So it covers the entire circular patch. Entire top surface. Light rays go into air. Rarer, denser towards the normal. Denser, rarer away from the normal. Denser, rarer away from the normal. Denser, rarer goes along the boundary. So here goes along the boundary. So now remember, thickness here has not changed. Thickness here has not changed. Only thickness here has. So technically, if you see, this is going to be X. This is going to be Y. This is going to be Z. This X and Y will not change. Why? This is 30 centimeters. This is 4 centimeters. These two have not changed. So the X and Y won't change. So only this part we have to carefully find. Only that part we have to carefully find. Write there a small sentence. The bottom layer of water thickness and the glass layer thickness has not changed. The bottom layer water thickness and the glass thickness has not changed. And the glass thickness have not changed. Therefore, X and Y values will not change. 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 We only need to find Z. We only need to find Z. We only need to find Z. Right? No? So here, if you carefully work this out, now X and Y already found earlier. X is 90 over root 7. Y is 8 over root 5. Addition is 37.5. Now here, let's work it out. Here, NW sin C, NA sin 90. NW is 4 over 3 sin C, NA sin 90. Sin C is 3 over 4. Sin C is 3 over 4 means right angle triangle. Opposite over hypotenuse 16 minus 9 root 7. Now tan C. Tan C is equal to opposite over adjacent. Opposite is Z. Adjacent is T. Also tan C is 3 over root 7. Z is 3T over root 7. Now if you take the radius completely, 45 centimeter is x plus y plus z. 45 centimeter x plus y plus z. X plus y plus z. Here 45 x plus y 37.5 plus z. Z you can separately find. 45 minus 37.5, that's going to be 7.5. Here 3t over root 7 equals 7.5. Thickness can be separately found in centimeters. Thickness you can find separately in centimeters. Root 7 you can separately find 2.65. 7.5 multiplied by 2.65 divided by 3. 6.625. 6.625 centimeters. There you go. Easily you can find 6.625 centimeters. Right now? Quickly write down. Finish writing. So it's an important concept. Some of you will ask questions as well. X and Y can't change. Why? 30 and 4. They are not changing. If 30 and 4 are not changing, X and Y won't change. Only the Z will change. If you want, you can calculate from here and go. Same answer you will get. Okay? Same answer you will get. Okay. Right. Question 5. Question number 5. So state the conditions under which total internal, I'm sure you can answer that by now. You go back to the question directly. A ray of monochromatic light travels in air, enters a long solid fiber, N1 1.52. Calculate the critical angle for plastic air interface. Calculate the critical angle for plastic air interface. Critical angle, plastic 1.52. NA is 1, goes along the boundary. NP sin C, NA sin 90, 1.52 sin C, sin 90. Sin C is 101.52. Okay. C is equal to sin inverse 101.52. 101.52. So divide and take it. So I don't want to waste time calculating. I'm sure you can do the calculation. Huh? I'm sure you can do the calculation. So this part and all, the calculation part, I won't waste time. You all can do it. Right? Hence show that the ray undergoes total internal reflection at surface PQ. For any angle of theta, disregard theta equals 0. For any angle of theta, disregard theta equals 0. So here PQ, here PQ, here you go. I want you to focus on the word. For any angle of theta. That means angle of incidence can change from 0 to 90. They are telling you in the question, disregard theta equals 0. Don't consider theta equals 0. That means from theta 1 minute up to 90, any angle, total internal reflection takes place. Right. Okay, no? So be very carefully think. It's very easy. Logic. When the angle of incidence increases, when theta increases, when theta increases, when theta increases, angle here, R1 will also increase. R1 also will increase. I'll show you. Theta there, rare denser towards R1. Here R1, here R2. Don't forget here 90. Huh? Horizontal vertical line 90. Okay, no? Right. Now look at the logic. Focus on the logic. When theta increases, R1 increases, R1 increases, R2 will what? Reduce. Why? R1 plus R2 is 90. When R1 is increasing, R2 is reducing. When R1 is increasing, R2 is what? Reducing. Okay, no? Right. Now look. When theta equals theta maximum, that is 90, R1 equals critical angle. If R1 equals critical angle, now I will need the critical angle here. Somebody quickly tell me, Vilu. Sine inverse, put in the chat. Sine inverse 101.52. Somebody. Sine inverse 101.52. Somebody quickly tell me the angle, Vilu, in the chat. Quickly now. If you quickly tell, I can find the answer quick. Hmm? Nobody is telling no. What is sine inverse? 101.52. 1 divided by 1.52. 0.6579. 0.6579. None of you all must tell no. Quickly tell. Quickly tell the angle. Now the angle difficult to work. 0.6579. So y'all are not even 0.6579. 0.6579 means 41 degree 41 degree 8 minutes. Okay, let's say 41. Yeah. 6579. Okay. So here you can calculate what is R2? 90, 89, 60 minus critical angle. Critical angle 41, 8. 52 minutes, 48, 52. Now what is 48, 52? 48, 52 is greater than critical angle. Therefore, total internal reflection takes place. Total internal reflection will occur. Now, look at this. For the biggest angle, this will be the smallest. Smallest also total internal reflection takes place. If the angle becomes smaller, this will become smaller, this will become smaller, that will become larger. If that becomes larger, anyway, it will be greater than the critical angle. Understood the logic? Understood the logic? For the maximum angle, this is minimum. For the maximum angle, R1 equals C, R2 is minimum. Minimum angle also more than critical angle. So total internal reflection takes place. Total internal reflection takes place. So for the minimum angle also total internal reflection occurs means anything more than the minimum, anyway total internal reflection will take place. Right there, Will? Right there. That's right. That's right. For maximum angle of incidence, for maximum angle of incidence, for maximum angle of incidence, the angle on surface PQ will be minimum. The angle on surface PQ will be minimum. The angle on surface PQ will be minimum. And the minimum angle also is greater than the critical angle. And the minimum angle is also greater than the critical angle. Minimum angle is also greater than the critical angle. Therefore, when theta reduces from 90 degrees, when theta reduces from 90 degrees, when theta reduces from 90 degrees, R2 will be more than the minimum. R2 will be more than the minimum. Therefore, total internal reflection will take place. Therefore, total internal reflection will take place. So for the minimum angle, total internal reflection occurs means for any other angle, total internal reflection will occur. Okay, no? Therefore, right? For any angle of theta, total internal reflection will take place. For any angle of theta, total internal reflection will take place. You all must find and give the angles quickly, otherwise. At part B. Now the above fiber is completely surrounded by another plastic material of refractive index 1.52. Determine the maximum value for theta for rays to undergo total internal reflection at surface PQ. Right. Now part B. Right now. So here we have here 1.48. Refractive index 1.48. Here refractive index 1.52. What are they asking you? Determine the maximum value for theta for the rays to undergo total internal reflection. Theta max. Rarer denser towards the normal. Total internal reflection means along the boundary. Here critical angle, let's say C1. C1. Carefully apply. 1.52 sin C1. 1.48 sin 9. Sin C1 1.48 divided by 1.52. C1 equals sine inverse 1.48 divided by 1.52. 1.48 divided by 1.52. I have to find it quickly using the log table. I hope you will quickly find and tell me the answer. 101.48 divided by 0.9737. 0.9737. Sine inverse 0.9737. Find the critical angle. Point 9737. $76.50. Okay, approximately 76.50. Let's say. If this is 76.50, find R1. C1 plus R1 is 90 degrees. R1 is 89.60 minus 76.50. 13 degree 10. 13 degree 10. Apply carefully. NA sine theta max 1.52 sine 13 degree 10 minutes. Sine theta max 1.52 sine 13 degrees minutes. Sine 13 degrees 10 minutes. 13 degree 10 minutes. 0.2267. Point 2278. 0.2278. I'm quickly doing it. So check the calculation carefully. 1.52 multiplied by 0.2278. 0.3463. 0.3463. Sine theta max. Theta max is sine inverse 0.3463. 0.3463. 0.3463. 20 degrees 12 13. 3463. 20 degrees 15 minutes, something like that. You will get. So maximum angle here. So anything more than that, R will increase. R will increase means C will be less. So maximum angle is at the critical. So think now logically. More than this means R1 will be more, R1 is more, C1 will be less. Less means total internal reflection can't occur, it will reflect. Okay. Show that theta equal 80, ray will not emerge into air. Theta equal 80, ray will not emerge into air. So see here. So again, you must find it step by step and work. Now angle maximum is 20. Anything more than that means it will refract outside. So 80 here means here R1, here R2. So your job there, you have to quickly find it. So NA sine 80, 1.52 sine R1. Sine 80. Point 9848 divided by 1.52 sine R1. 0.9848. 0.9848 divided by 1.52. 0.6479. 0.6479. R1 is sine inverse 0.6479. R1 you can find. 0.6479. Twenty-three. 40 degrees 23 minutes. R1 plus R2 is equal to 90. 40 degrees 23 minutes. 8960. 8960 minus 4023. 7. 37. 4937. So what is 4937? We know the critical angle here. Critical angle is 7650. Light rays will refract. Denser, rarer away. Here R3. Here R3. So carefully you must calculate this. So 1.52 sine 4937. 4937. Actually, we can do the calculation here. Be easier. Yeah. 1.52 sine 4937. 1.48 sine R3. 4937, 1.48. 4937. 4937. 2935. 49 degrees, 37 minutes. If you all have your logbooks, quickly tell me. Right. 4937. 49. 7604. 'Can't see it was a problem. 4937. So I'll just take the round off value and work. 49 degrees, 7615. 0.7615. Multiply will. Right. 1.52 multiplied by 0.7615 divided by 1.48. From this, you'll get 0.7821 sine R3. R3 is sine inverse 0.7821. So R1 0.7821. 51 degrees, 51 degrees, 27 minutes. 51 degrees, 27 minutes means don't forget now here critical angle. It's all here. Critical angle there. 1.48 sine C1, NA sine 90. Sine C1 is 101.48. C1 is sine inverse 101.48. Carefully solve it. 1 divided by 1.48, 0.6757. Sine inverse 0.6757. 0.6757. Let's find the critical angle. 0.6757. 4230. Right? No. R3 is greater than 4230. Therefore, total internal reflection occurs. So here total internal reflection will take place. So this part you must separately solve it from here, there, and from here to here. Total internal reflection will take place. So it's best always if you can do the log calculations. Obviously, some of you all are very lazy, all don't do log calculations. Therefore, otherwise, quickly we can solve this. So here, R1 80 means 80 here, R1 I can find. Once I know R1, I can find R2. R2 is less than the critical angle, don't forget. This R2 here, less than the critical angle. What's the critical angle? Critical angle we found earlier, 7650. Critical angle 7650. Critical angle 7650. Therefore, light will refract. Light will refract. Once light refracts, apply here, you can find R3. Sin R3 you can find. Once you know R3, here was R3, find the critical angle. R3 is more than the critical angle. Here, air interface critical angle. More than the critical angle. So, total internal reflection will take place. Okay, now. So, 5 past paper questions done. So, redo this. The ones who have not done this, make sure you redo this. Try to get the answers. Some of the answers I gave are approximate because I quickly found it using the tables. But you all correctly use the log table and do it. Okay. I'll catch you all again on another session of helpline. Make sure you keep working questions. Some of you all have not worked the questions, but work the questions, because the more questions you work, the better you'll become at what you're doing. Okay. Take care. Make sure you keep on working. Good night.